Okay, y'all, we're gonna get straight into it. Step one, when solving your dosage calculation problems, the first thing you write down on your paper before you do anything else is write down your anchor unit. And your anchor unit is basically the unit of measure that the question desires. So in this example, it asks us to calculate the flow rate in drips per minute. Drips per minute is our anchor unit. If the question were to ask us how many milliliters will we give for intramuscular injection, milliliters will be our anchor unit. If it asks us how many tablets will you administer, tablets will be our anchor unit. So step two is you're just going to pull from your question the number that is associated with your anchor unit, okay? And I just want to note here that if you have an IV flow rate equation like milliliters per hour or drips per minute like we do below, you want to make sure you start with the first unit of measure. So for example, if it asks for drops per minute, you're going to start with drops here. If it asks for milliliters an hour, you're going to start with milliliters here, okay? So it's called an anchor unit because your equation is going to literally begin and end with this unit of measure, okay? So whatever your anchor unit is that you put in step one, that's where you're going to start step two with. So that's why we have 30 drops. So step three is what we call work and convert, okay, y'all? So basically, we're going to look at our problem and we're going to look at what we have available or what we have on hand as well as the doctor's orders in order to plug in our numbers, okay? So when we look below, we see that we have drops per minute because that's our anchor unit. And then in step two, we listed 30 drops because 30 is the number associated with our anchor unit, which is drops. And we put drops first because that's the first unit of measure listed. And then look, underneath the number 30, we put 1 because 1 milliliter is equivalent to 30 drops according to our drop factor. And again, like I said, you must have correlating units diagonal or across from each other, one on the top, one on the bottom, which is why we put 200 milliliters in the next step, okay? Then underneath that, we put 2 hours because the doctor ordered us to infuse this medication 200 milliliters over 2 hours, and then we know that because we have hours there, we must have hours diagonal, and we know that 1 hour is equivalent to 60 minutes. And another thing I want you all to notice is that I didn't just plug in my numbers in just any old random box. I went in a specific order, which I'll show you here. This is also key because, like I said, not only do we need to make sure that our units are correlating, diagonal from each other, one on the top, one on the bottom, you want to make sure that you're flowing in a specific order. So step four is basically going to make sure that your problem is set up correctly, okay? So if you were concerned in step three and you wasn't sure if you set up everything correctly, this is where we're going to check our work, okay? So as you see here, like we stated in step three, you should have a correlating unit diagonal from each other. So you see here, I have 1 milliliter, and across from that is 200 milliliters. I have 2 hours, and across from that is 1 hour. So that means we can cancel those units out. As long as you have a correlating unit, one on the top, one on the bottom, you can cancel out those units. And if done correctly, you should only be left with your anchor unit. And as you see here, once we cancel out all of our other units that we listed in our problem, we are only left with drops as well as minutes, which is our anchor unit, drops per minute. Now we're on to our final step, step 5, and in this step we're just going to do the math. So we're just going to multiply across our top boxes first. So 30 times 200 times 1 equals 6,000. Then we're going to multiply across on our bottom row. 1 times 2 times 60 is 120. And then we're just going to divide our totals. So we're going to divide 6,000 into 120, and that will give us our answer of 50 drops per minute. And I just want to note that if the boxes are foreign to you, it's literally the exact same as multiplication and division. I have that example here. If you want to do it the traditional way, that's fine. If you want to use the boxes, that's okay as well. But it's the exact same whether you use the boxes or the traditional method of setting up the problem. So now that I've shown you how I do dosage calculations in 5 steps, I'm now going to demonstrate to you how to solve this problem that you see on your screen here. We're doing milliliters an hour. So remember, going back to our basic conversions, there should be a milliliter here, right? Right next to it. So 500 milliliters. And what do we know? What do we have? We have over 90 minutes. But we're not done because they want us to figure out milliliters an hour, right? and this is milliliter per minute. So in order to do that, we know that 60 minutes is in 1 hour. Now we can do our math. Let's check our math. So we're able to cancel our minutes out, and we're only left with milliliters and hours, which is what they are calling for. So now we just simply do the math. We're going to do 500 times 60, which is 30,000, divided by 90 times 1, which is simply 90. So 30,000 divided by 90 is 333.3, okay? Okay guys, if you feel like you got value from my video, please be sure to like, comment, and subscribe. And I have tons of freebies just like what you see on your screen, such as revision templates, pharmacology cards, free ebooks, whatever you need to help you matriculate through nursing school, pass NCLEX, and start your journey as a new graduate nurse. Of course, if you have questions, make sure you put them down below and I will answer them, whether it's about dosage calculations or study prep or NCLEX prep, anything you need, just be sure to hit me up, okay? Until next time, I'll see you all later.